Hello! So in this video I want to just discuss the basics, a little bit of an introduction into what a differential operator actually is, because it's quite an interesting thing. So up until now we have been looking at this form, so it's a second order linear differential equation as exactly that. It's just a differential equation, okay? And what we've been trying to do is address the problem of try and find solutions to this equation. So in other words, what function, so y equals something something something, so what we have to plug into here, and then find the derivative of it and plug it into here, and find the second derivative and put into here. What function will satisfy this equation? And that's kind of how I've been looking at this thing up until now. Okay, but what I now want you to do, or what we're now going to start to do, is start and look at this as something called a differential operator. A differential operator. Okay, now what is an operator? Well, an operator, if you just think an operator, or just you say the word operates, it derives from the word operates. Operates is just another word for works. So it's just how something works. Now, essentially, this is just a differential operator is just a function that works by differential equations. Okay, it's a function. It's a function that works by differential equations. So it's just some function. A differential operator is just some function that works by differential equations. Okay, that works by differential equations, right? So what do I mean by that? Well, let's just remind ourselves of the definition of a function. Okay, so a function. Let's suppose we have a function. Let's draw it out like this. You probably did this in primary school or whatever. Basically, what you do is you put some number in. Let's say 2, and you have some function. Let's say y equals, I don't know, 3x plus 4. Okay, so x is our input. So x is our input. Okay, and y is our output. Okay, so in other words, when you put 2 in, what do you get out? Well, you get 3 times 2, which is 6, plus 4, which is 10. So you get 10 out. Okay, so our output is 10. Okay, so the idea is that basically, a function is you put a value in, and you get a value out. Okay, and that's how a function works. Okay. And then if you put more and more of these values in, so basically if you put successive values in, so all of the possible numbers that you can put in on this right-hand side, then effectively, and plot them on a graph, then basically you can draw this function on a graph. Okay, so something like that. So it'll be something like that. Okay, so that's all a function is. Basically, you put a value in and you get a value out. Well, now what I'm doing is instead of putting a value in, okay, with a differential operator. So this is something known as a function, okay. But now with a differential operator, the idea is that instead of putting a value in, I want to put a function in. Okay, so I put some function in here, okay, and I get another function out. Okay, and just the basic idea behind differentiation, that is a differential operator. So say, for example, if I put in y equals x squared, my differential operator, which is sometimes denoted by this, or it could be denoted by a capital D, or if it's partial derivatives, it might be the derivative with respect to x. Okay, it's there's very different ways that you can write it. You can always write it like this. You could almost write it like f dash of x. There's loads of different ways of writing it. There's also y dash. There's loads of different ways of writing it. These are all ways of writing this differential operator. So essentially, you've been familiar with differential operators for years. You just didn't know that you were using them, okay? But the idea is basically you put a function in, and you get a function out. So the function, let's just use this differential operator notation. So d dx of y, okay? So that's the d dx of y, and of course it's going to be 2x. Okay, 2x. You're just differentiating it, and that's what differential operator is. Well, why don't we call differential operators? Why do we call them operators and not functions? Well, look what we're putting in. We're putting functions in, and we're getting functions out. So with a function case, we just put a value in. Yeah, we just put a value in, and we get a value out. Right? But now with differential operators, I'm now putting functions in. Okay, so I have to call them something different, because if I suddenly call if I call this thing in here a function, then what I'm saying is I put a function into a function, I get a function out. that's not right, okay? What it is basically just a differential operator. Just basically works on a function. So now, because I'm putting functions in and I'm getting functions out, I call it something different, and that's why I call it an operator, okay? So it's actually a little bit more complex than a function because it's dealing with functions themselves. So it's, if you like, a little bit more. It's a little bit not layered. You know, you start off with a value, and you know that's how you build your function. Okay. Well, now what we're doing is we're taking that function, if you like, and we're differentiating it. So instead of just dealing with values, now dealing with functions. It's like we're adding another layer to the onion. Okay. So okay, all I'm just going to do now is I'm going to take my second order differential equation. So a of t times y dash plus b of t times y. Okay, and I'm going to call this is my operator. So this is my operator. Let me just write it out properly. So my operator is a linear operator because this thing here is linear. It's a linear function. Okay, it's a linear differential. Well, not a function. It's an equation. But this is a linear equation because obviously, you know, there's only coefficients multiplied by it. You know, each derivative and each function has got its own separate term, and it's not being raised to any power other than 1. So it's not being squared or cubed or whatever. You know, this isn't being cubed or whatever. You know, highest power is 1. So it's linear, so that's why we use an L here, okay? And it's a linear operator involving the function y, okay? And the variable which it uses is t. Okay, so this is now how I'm going to define my linear operator. Okay, now let me just try and show you by an example, because I think if I show you an example, hopefully it'll make it a little bit clear. So let's change this thing, this a of t, instead of just being general, let's use a specific example, and let's say it's t squared. And let's say this is bt is going to be, I don't know, e to the 2t. Okay, so now what we've got my differential operator defined as this thing now. Okay, so in other words, if I put a function in, let's say I put my function, I don't know, y equals sine t. Let's say y equals sine t. I put my y equals sine t into my operator. Okay, so now what's my output going to be? Well, my output is going to be when I put y equals sine t into that operator. So in other words, when I put y equals sine t into the operator. So let me just try and write it in here. Okay, so y equals sine of t. Okay, so I put that y equals sine t into my operator. You know, this notation is a bit like f of x, yeah? F of x equals x squared, for example. Okay, well, when I put a value in, I just replace it with some value, so x equals 2. Okay, and this then becomes 4, right? So now all I'm doing is I'm doing exactly the same, except now I'm putting a function instead of just a value. Okay, so this let's start off down this end. So this y, so let me just write it out again. So this is e to the 2t. Okay, so let's try and work out what we do when we're putting this in. So basically we need not just y, we also need the, you know, this is y equals sine t. So basically the idea is I'm just trying to put that into this equation. So y dash equals cos t and y double dash equals minus sine t. So now I've got all the pieces which I need to write out what my output of my linear operator is going to be. So y equals sine t, let's just put that in there. So y equals sine t. Y equals sine t. Now I've done that, so let's put y dash into there. Okay, so y dash into there, so that's cos t. Right, and y double dash, let's put that into there. So minus sine t. Okay, and that is my output. That is my output of my linear operator. So in other words, I can say now that this thing is the output of my linear operator. Right, that's my output of my linear operator. So in other words, let me just try and draw this out. Okay, so hopefully I've sort of drawn this out a bit neater. So in other words, when I put my function into my linear operator, this is how my linear operator is defined in this box here. Okay, so when I put my function y equals sine t into this linear operator, this is what I get out. So it's exactly the same idea as a function, except now instead, because I'm putting a function in instead of just a value, I can no longer call it a function. I have to call this thing an operator. An operator. Okay, and a differential operator is just a you know, an operator. I'm trying to do these things at once. Differential I think that's right. Differential operator is just basically putting in a function, and it's just an operator that uses differentiation. That's why it's called a differential operator. Okay, so hopefully that makes things a little bit clearer.